So this video is the first in a series of videos regarding the laws of exponents. Today we're just going to look at the multiplication properties of exponents, and particularly the product of powers and the power of a power property. So let's start with the product of powers first. This property tells us that a to the m multiplied by a to the n equals a to the power of m plus n. Essentially what the rule is telling us is that if we have powers with the same base and we're multiplying them together, we can add the exponents. I'm going to show you why we can add the exponents with a couple of quick examples. 2 squared times 2 cubed equals 2 to the 5th power. The reason we can add the exponents is for the following reason. 2 squared could be written in expanded form as 2 times 2, and 2 cubed could be written as 2 times 2 times 2. And what we have here is a string of multiplication, and we can see once it's expanded out, the 2 is repeatedly being multiplied 5 times. So in the future, instead of expanding it out like we have here, we can apply the rule of adding the exponents when the bases are the same. This also works for variables. X to the 4th multiplied by x squared. X to the 4th is x times x times x times x. And we're going to multiply that by x squared, which is x times x. And here we can see that the x is repeatedly multiplied 6 times. So that's the product of powers rule. The next rule is the power of a power property. With this rule, we see that a raised to the mth power raised to the nth power is equal to a to the m times n power. Here's why we can multiply the exponents. In the first problem, in the parentheses, we have 2 squared. The exponent outside the parentheses is telling us we're going to multiply what's inside repeatedly 3 times. We can see again we have a string of multiplication here, and that the 2 is being repeatedly multiplied once, twice, 3 times, 4 times, 5 times, 6 times. So the answer here would be 2 to the power of 6. Inside the parentheses we have 2x squared, and we're being asked to repeatedly multiply this 3 times. So here's 2x squared in expanded form. We're gonna multiply that out 3 times. Now we can see here that the 2 is repeatedly multiplied 3 times, so this would be 2 to the 3rd. And the x's are repeatedly multiplied 2, 4, 6 times, so this would be x to the 6th. So the answer is 2 cubed x to the 6th. One little hack I like for this is that when I see a value in the parentheses that doesn't have an exponent, I like to just add in the 1 there. And then when I go to multiply my exponents, I don't miss that 1 and actually say 2 times 3 is 6. I can see I'm multiplying the exponent there. 3 times 1 is 3, and 2 times 3 is 6. 2 cubed is 8, and x squared to the 3rd power is x to the 6th. Our final example looks a little more chaotic, but it's really no different. So the way I like to approach this is I follow the same pattern here. I like to just expand it out, and I do that for each term. And what that does for me is it highlights the fact here that we have nothing but multiplication in the problem. And I can take advantage now of the commutative property. So I can rearrange this into 3 times 5 times 2. We're going to multiply that by x squared times negative x to the power of 4 multiplied by y. So now we have that reorganized. We can start simplifying this now. There's a little more clarity. 3 times 5 is 15, multiplied by 2 is 30. This part might confuse you, but think about what this is saying. It's saying we have negative x multiplied by negative x multiplied by negative x multiplied by negative x. A negative times a negative is a positive. Negative times a negative is a positive. I end up multiplying a positive times a positive, so this will end up being x to the fourth, and x squared times x to the fourth is x to the sixth. And the y, there's nothing else we can do with that, so we bring that down with the problem, and there's our final answer, 30x to the sixth y. So I hope this video will help you out. The methods that I use in here have helped me out when I was a student, and it helped clarify what I needed to do as I was simplifying each problem. So good luck with your work, and we'll see you in the next episode tomorrow.